Hard drives are one of those things that keep me up at night because it is the large component inside the computer that, besides the fans, still has moving parts. This is a hard drive with the top taken off. This component here is called the head, and it writes data onto and reads data from these silver disks, which are called platters. Most hard drive platters spin at 7200 revolutions per minute, although there are hard drives which have platter speeds which range from 5400 to as high as 15,000 revolutions per minute. The read-write head here never actually touches the platter, it just skims above it. Data is recorded onto the outside of the platter when the hard drive is empty, and then gradually moves inwards towards the center of the platter as the hard drive gets filled up. This is why mechanical hard drive read and write speeds slow down as they fill up, because less data is moving under the head as it gets towards the center, in the same way that a bicycle wheel spins slower as you get towards the center of the wheel. And we are going to see this effect in some graphs in episode 8. You will now understand why hard drives make me so nervous. If, for example, the platters stop spinning because the platter motor wears out, or the read-write head touches the platter, wiping out data as it does so, or the platter has surface imperfections so that data is not properly recorded, that data could be lost forever, and at the very least cost hundreds of dollars to retrieve. Now, we mitigate this by using extremely high quality enterprise hard drives, which are manufactured to very high tolerances, and they have been tested and validated for 24/7 use. These are about twice the cost of regular desktop hard drives, but their reliability makes it worthwhile, and we have had very positive results with enterprise hard drives. But I need to emphasize that it is a mechanical device, and like all mechanical devices, it will eventually go the way of all flesh. The advantage of mechanical hard drives is that they can store a lot of data. The current maximum is 3 terabytes or 3000 gigabytes, though I have heard that 4 terabyte drives were recently introduced. They are also reasonably inexpensive, certainly in comparison to solid-state hard drives. The downside, as I have just stated, is that all mechanical hard drives will eventually fail, though I can say that 98% of our hard drives make it past the 3-year mark, which is well above the industry average. Solid-state hard drives, on the other hand, have no moving parts at all. As you can see when the top is taken off, the whole drive is made up completely of chips. The hard drive stores its data on these chips here. And this is why solid-state hard drives are much faster than mechanical hard drives. There is no read-write head that has to physically read or write data. Everything is stored electronically on these chips. The advantage of solid-state hard drives is that they have no moving parts, so they are very fast, and this also makes them very reliable. The disadvantage is that solid-state hard drives currently come in relatively small capacities. The largest solid-state hard drive can currently hold about 600 gigabytes, and they are quite expensive. As of January 2012, that same 600 gigabyte hard drive costs over $1,000. The other disadvantage is that the write capability of solid-state hard drive will eventually wear out so that you can only read data from it. But this usually takes around 5 years, and by this time, most people, certainly those people who use their computers for digital content creation, are ready to move on to a new computer anyway. Now, to see exactly how fast mechanical and solid-state hard drives are, take a look at episode 7.